So now let's go ahead and begin discussing our ACI VMM integration with Microsoft and Hyper-V. So we really have two modes of integration available to us depending on what the customer has. So we can either do integration with the Microsoft System Center Virtual Machine Manager, SCVMM, or we can also do it with that plus Azure PAC, which we'll talk about. So with System Center, all the policy management is done through the APIC, so all the configuration is done there and pushed to System Center. We'll take a look at that workflow in a moment. The licenses that are needed are, for the customer side, are going to be the Windows Server with Hyper-V and the SCVMM. And all discovery of virtual machines is done through OpFlex. So we said with VMware, it was done originally through discovery protocols like CDP and LLDP, and later just trusted through the pre-provision process. With Microsoft, we actually have a much more advanced, using Cisco created but released into the public, and we're going to talk a lot more about in a module here or a sub-module here in just a few slides here, being the OpFlex protocol that was developed and released to the IETF, and we're actually going to talk about it with OpenStack as well, and it's being adopted by a number of companies. So it is actually an open standard. It's going to be ratified as an RFC here very soon, along with the group-based policy. Those are the two main things that Cisco created out of the NCME business unit that spin in that became ACI and released as initial drafts and ultimately ratified into RFCs. So with this, we have a lot of very intelligent information that we can send back and forth to the hypervisor and learn about the VMs. So with this, the encapsulations of VM traffic that's coming from the hypervisor into the leaf, it can be done either with standard VLAN tagging with .1Q, or very soon we're going to be supporting the NVGRE header as well. Now our hardware already does. We just have to work out a few last-minute API things with Microsoft. So the plugin installation is going to be manual though. So we do have to install the plugin into Microsoft System Center VMM. The other option is to integrate with Azure PAC. Now the nice thing about this is that the plugin is integrated with Azure PAC. And this is essentially a superset of System Center VMM Manager. So which is a little bit redundant, so VM Manager. So this essentially is everything that System Center is, but adding in Azure PAC to really give the customer this public cloud type feel. So we can create virtual private clouds really inside our organization. So the policy management or configuration can be done through the APIC or through a single pane of glass through Azure PAC, which would be very analogous to what we just finished talking about with regard to VMware and the ACI plugin. Azure PAC has always been this way, so we do everything through a single pane of glass. Now, you still need the Windows Server with Hyper-V, the SCVMM, but you can also integrate the Azure PAC, which is really a free plugin, so you don't have to spend any additional money to get a lot more functionality. I highly recommend that anyone doing Hyper-V adds in Windows Azure PAC. So then the VM discovery is still OpFlex. The encapsulations are the same, but like I mentioned, the plugin is now integrated. So let's take a look at the workflow. And again, this is set to on-click. My animation, I double checked it, but for whatever reason, and so was the last one with VMware, for whatever reason, it is just adamant that it's going to go automated. So I'm going to try to talk through this. I might have to stop and kind of go back the animation a little bit if it goes too fast for me. So there are still separate roles, the APIC admin and the SCVMM admin. Now the APIC admin is still going to have to set up all of the fabric access policies. That much will never change. The idea of ACI and really SDN and overlays and NVO or network virtualization overlays is that we set up the fabric, the infrastructure or the underlay once and done. So once we set that up, unless we add new leafs or change the fact that a port might have to be hard-coded to 1 gig Ethernet or 100 meg or something more infrastructure related like that, or that we need to have CDP turned on or off on an interface, something like that, it should really be one of the things that we set up once and then we're pretty much done. And then we set up our domains. Of course, the APIC admin will still have to set up the VMM domain pointing over to Microsoft SCVMM. And then from there, the tenant overlay should be able to take care of everything else. Whether the tenant is provisioned, so the policy, the overlay is provisioned through the APIC, or later when we talk about Azure PAC, or when we were earlier talking about VMware with ACI plugin, all of that could happen from the other side. So really it doesn't matter, but the idea is that the tenant, the overlay, can do everything from there. So once we've done that, we've created our VMM domain, and the Cisco APIC and Microsoft SCVM do an initial handshake, then this is going to create a virtual switch, so a Hyper-V virtual switch. And this is where the animation is going a little bit too quickly. So at this point, the SCVMM will get involved, and they will attach the hypervisor to that virtual switch, just like adding hosts to a DVS in VMware. Now, ACI will learn the location of the Hyper-V, through the OpFlex protocol, because that information is going to be told back to APIC, and APIC is going to learn that through OpFlex. And there's an OpFlex agent that's essentially running on each hypervisor. So then the APIC admin would create the policy and the EPGs. This would automatically map EPGs to VMM networks, create those VMM networks, and then the Microsoft admin would go ahead and instantiate the VMs. And again, the animation's going too fast. Instantiate the VMs and assign those to the VM networks, and then go ahead and, once the APIC saw that attach of the endpoints that it learned about through the OpFlex protocol, it would go ahead and push the policy down to the leaf if we're doing on demand. So when we look at Azure PAC integration, we note one thing, that this requires Windows Server 2012. It requires Windows System Center, VMM, release 2012 release 2 with the SPF or Service Provider Foundation. So on top of our servers, we have our System Center with SPF, and then the Azure PAC plugin. So with the Azure PAC, we then have, it provides a single pane of glass for, as we mentioned, the definition, the creation, and the management for really a cloud service. And it's really divided into two separate portions: the provider or admin portal, and then the customer self-service tenant portal. And then the ACI plugin enables the management of all the network infrastructure through the APIC REST API. So here's kind of an example interface of the admin experience, the service management portal, okay, or this portion over here, the provider portal. And we essentially see that once we do the integration with ACI and we register our ACI APIC or REST endpoint, which is the APIC, then we have the ability to add and configure service providers, so the APIC IP and login credentials. And users can do things like billing and chargeback, things like that. Now the tenant experience, so what the individual tenants see and are able to create and consume, is they see the different ACI networks that have been provided to them by their provider, and they are able to view these endpoint groups in particular tenants and however many VLANs or subnets they have, and use these services that the tenant has access to. So all the application network profiles are created through Azure PAC, and they're pushed to the APIC using REST. So here's a workflow example of this. We have the APIC admin that's already done the basic fabric access policy, and they've done the VMM domain creation once. So that already did the initial handshake. And then past that, the Azure PAC tenant will, as they need to, talk through their provider, through their tenant portal is what I meant to say, and create the application policy, which will automatically push through REST, push that profile, and create that application network policy or profile over in the ACI APIC. It will then dynamically get the VLANs that were allocated for each EPG, and those will be pushed into Microsoft System Center to the OpFlex agent to each hypervisor in the distributed switch, and the admin will, or really the Azure PAC tenant, will instantiate their VMs, and it will automatically indicate the endpoint attached to the leaf, and the APIC will push the policy. So now let's take a moment and talk about integration with ACI and OpenStack. So OpenStack, there are a couple methods with OpenStack as well. The older and first method was to have the OpenStack APIC plugin added. And by the way, maybe I should kind of take a step back and just define OpenStack for those that are unaware or don't know a lot about it. OpenStack, of course, was initially developed as a collaboration between Rackspace and NASA. And the idea was to create a public cloud experience that really an open source public cloud control platform and experience that was similar to or even rivaled Amazon Web Services, which is hugely scalable, built around the idea of stateless machines where if one dies, we can just bring up another automatically. If we lose storage nodes, we can automatically replicate files with parity bits, or where they're stored on other, not even parity bits, but where they're stored on other distributed storage platforms, and do things like support VMs, support, really it started out fairly small but with a grand vision, and today, many years later, has developed into a huge program that has many different modules. So everything with OpenStack is very modular, and you can pick and choose as an organization or service provider which modules you want to install, which ones you might need. And so we have things, well actually first of all, I should also mention it left being controlled by NASA and Rackspace. Really they relinquished control into a open governance body, a board of directors that meets and decides essentially what goes into the next release. And OpenStack releases are based around a time-based controlled 6-month release schedule. So every 6 months they release a new version. I think currently we're running on Kilo, and we're getting ready to see a new version here in just a few months. As of the time of this recording, which is roughly beginning of August 2015. So as of actually, I believe it was Juno release, we had, Cisco had contributed, well first of all, many different companies contribute to OpenStack as well as many different individuals. Cisco being one of the largest throughout really almost its entire history of OpenStack. IBM, Red Hat being some other very large contributors. HP, I think, contributes quite a bit as well. So with OpenStack, you have your choice of hypervisors. You're not limited to one. So you could use Red Hat KVM, you could use Citrix Zen Server, you could use Microsoft Hyper-V, I think is even now finally supported in the latest Kilo release. You can even use VMware ESXi. Of course, ESXi, the hypervisor is free. It's vCenter and other things that cost money. So you do have your choice of hypervisor. So there are different modules or components to OpenStack. The module that basically shows you the web-based portal is called Horizons, even though most people create their own. And the compute or virtual machine is called Nova. The networking used to be called Quantum. Now it's called Neutron. So you see that up here, Neutron networking. So that's the controller node in OpenStack that deals with all of the networking. We have things like Glance, which is for image repositories, ISO, QEMU, things like that, OVAs. We have Cinder, which is block level storage, right, like Cinder blocks. We have, what else? We have Swift, which is object storage or file level storage. We have Ironic, which is ironic because it controls bare metal. So anyhow, there's all sorts of different modules. I've only touched on some of them. But we're mainly focused here around Neutron, as this deals with our networking and our APIC. So that was just kind of a very quick 10-minute overview, not even that, 1-minute overview of OpenStack. We will have a future class here that is dedicated to just OpenStack, not only helping you understand it, but also getting deep down into how to set it up and even how to fully customize it. It's written 100% in Python, and there's a lot that you can do, really anything that you want to do to customize it. Taking a look at how ACI integrates, we have our controller node being the Neutron networking, and we have this APIC plugin. So the APIC drivers map via REST API, and we talked a lot about that. We'll be taking a lot more of a look at that in a future module with ACI and programmability, and how to control it through REST, as well as how to control it through Python native SDK. But the networking component of OpenStack maps to an APIC EPG, and then we have other components that map, such as router maps to an L3 out. It says contract here, but it really should be an L3 out. So the ACI fabric is going to offer our distributed L2 and L3, okay, without the need for an L3 out agent. And this is going to be applied, of course, at the top of rack. The OVS driver in OpenStack Neutron selects the VLAN or VXLAN tag per the network configuration, and it automatically configures OVS through the OVS DB protocol. And then OVS applies the VLAN or VXLAN per the network, and then for security, we're not using contracts, but IP tables are done through security native in OpenStack. So this is actually not a component of ACI in this particular early release model. Now, as I mentioned, there's two models of integration, and both of them are available today, but early on, I don't mean to say now we're early, but earlier, about a year ago, this was our option. Actually, it wasn't quite a year ago. I believe it was November of 2014. So if we're using that Neutron to ACI API mapping, then in that older model, ACI called something a tenant. OpenStack also calls this a tenant. ACI has something called an application profile or application network profile. Really, there's no equivalent of this naming in OpenStack. ACI has an EPG plus a bridge domain, and together those in OpenStack are called a network. Now, everything is done from the OpenStack side, from the Horizons dashboard, and it's pushed to ACI. So if we create a network in and we'll take a look at a workflow here in a moment, but if we create a network in OpenStack, that is going to push a EPG and a bridge domain, essentially of the same name, to the ACI APIC. If we create a subnet in OpenStack, it will push a subnet to ACI. If we create a so we do note that since we don't have the equivalent of an application profile, but EPGs fall under the application profile, when we create the tenant in OpenStack, it will automatically create the application profile with essentially the same name in ACI. So the subnet in OpenStack would create a subnet in ACI. The security group in OpenStack, that is not going to be pushed to ACI. That's not at all in ACI, so I just kind of have italicized here. That's handled by the host itself, meaning the, let's say, Linux virtual machine running IP tables. Okay, so or really the hypervisor, I should say, not the Linux virtual machine, but the KVM hypervisor, also Linux. So the security group rule also would be handled by the hypervisor host. If we create a router in OpenStack, that's going to create an L3 context in ACI. If we create a network external in OpenStack, that's going to create an L3 out in ACI. Now, we're going to talk a little bit more now about group-based policy in OpenStack. So as of the 2014.2 Juno release, and each of the OpenStack releases have these code words not only for all the internal modules, which can be confusing, but they begin to make sense, right? Anyway. They also have these course, code names for the releases. So the Juno release, the version is corresponding to the year and then the release. So since they're released every 6 months, typically about roughly, I think it's May and November. We had essentially the May release would be 2014.1, and I believe this was the November 2014 release, so 2014.2, codenamed Juno. So at this point, Cisco had long ago, back in, I believe, April of 2014, so well over a year ago now, made the OpFlex protocol and the group-based policy as, published them as initial drafts to the IETF, and they're still going through the review phase. It can take very long, 2-3 years to get something ratified into a standard. But these are open to everyone, right? So OpenStack already adopted the group-based policy into OpenStack release Juno and beyond, so we're in the Kilo now. And this gives everyone the opportunity to use group-based policy, and many other vendors have begun adopting this as well. And it also gives them the opportunity to use the OpFlex protocol to control or essentially declare the policy to a group-based policy, something that supports that standard of group-based policy, or soon to be standard, in OpenStack. So this maps ACI to current OpenStack components. Endpoint groups can create ports and security groups, or really ports and security groups in OpenStack create endpoint groups. And in OpenStack, security groups and security group rules create contracts in ACI. So whereas previously, in fact, let's just go into this slide, with the APIC plugin, all security was done on the hypervisor with IP tables itself. With if we're moving to the group-based policy plugin, then we actually do still create the security and security group rules, but instead of those being done in the IP tables, it gives us contracts, which gives us actually a larger choice of hypervisors. So before, it was pretty much KVM or Zen, Citrix Zen server that we had to use as the hypervisor to get that IP tables type functionality. We do have that somewhat in ESXi, but it's a little bit more difficult to set up with OpenStack. So with group-based policy, all the contract enforcement is done by the leaf switches, either the iLeaf, which is the physical leaf switch, or the vLeaf, which is that virtual switch. So here's the OpenStack integration. We see that we have the APIC tenant, or sorry, APIC admin, and of course they're still going to do the fabric access policies as well as the fabric policies, setting up MPBGP, etc. And then the OpenStack, well, also the APIC admin would essentially give to the OpenStack tenant admin or really the OpenStack provider admin, or they would go ahead and do the plugin for policy. So the OpenStack tenant is simply going to spin up their Nova instances, their VMs, and define their networks through Neutron, all of this done through the Horizons dashboard. And that's going to create network subnet and security group policy, which will then automatically be pushed as application network profiles, EPGs, and contracts to the APIC, and that will create the application. And then, of course, the OpenStack tenant would instantiate their VMs. And once they instantiate their VMs, we would see that, and policy would then be pushed down from the APIC to the leaf switch. Now, one other thing that I want to discuss is you have the ability to actually go out and test and try out all of this stuff through Cisco's demo cloud, or dCloud. So if you've never heard of or never been to or never made use of, dcloud.cisco.com, okay? HTTP dcloud.cisco.com. Definitely go out and take a look at this. It used to only be open to partners, but it's now open to end users as well. So even if you're a customer watching this, you have the ability to use this. Obviously, if you're Cisco internal, you definitely have access to this as well. You just have to create an account. Now, partners do have a few more labs that they can do. This slide only shows that there are 3 labs, and it only shows 2 of them pictured in the screenshot. But the current, at least partner visible labs are, I believe there's either 7 or 8 ACI specific labs. So you do have ACI APIC with OpenStack that you can test out. You can test out with VMware. You can test out with Microsoft Hyper-V. You can test out with VMware as kind of the base for VMs, but then with F5 LTMs, right? Your big IP local traffic manager, integration through L4 through 7 services. There is now also Citrix NetScaler as another lab. Another lab is ASA. And again, these are ACI with the layer 4 through 7 services. So there's a lot of different labs you can do. Most of them are simulator based. So you get the interaction with the GUI, the web user interface, but you don't necessarily have, and you can do all the REST API calls as well, but you don't necessarily have a data plane to verify anything on. There is one, at least as of the time of this recording, one lab, I can't recall which one it is, but one lab that does use real hardware and you can verify the data plane. Of course, because it uses a real fabric, it's much more limited in availability, typically being scheduled out much more often, a little bit harder to get a hold of. But the VM-based or simulator-based, actually they're not even VM, they are really a C220 server running the whole simulator. And by the way, if you are a partner, you are allowed access to the simulator. First of all, you can purchase a ACI simulator, which comes as a full C220 server. I think right now list price is like $18K, which is pretty expensive, but it's a really beefy C220 server that has embedded in it, really is, by the way, OpenStack that's running everything, but it's actually 2 spines, 2 leafs, and then we also have 3 APIC controllers. You have either 2 or 3 ESXi machines, and then you also have the vCenter server, and you have a few VMs on those ESXi machines. So you actually have the ability to test out quite a lot of integration with virtual machine. And if you even are a customer, an end user, and you do one of these labs with VM integration, that's what you're going to be working on. So you will be able to do the full, go and provision the VMs, attach them to the port groups that were created because ACI pushed the port group creation when an EPG was instantiated. You'll be able to walk through all of those labs. So definitely take advantage of that. Now, if you're a partner, you should have the ability to talk to your Cisco SE. And if they can't get a hold of it for you, you can certainly contact us at Lumos, and we should be able to give you control to, have to verify that you've signed the NDA and everything, but access to the ACI APIC simulator in a virtual machine format as well. You won't have a data plane, you won't have ESXi, you can't really do VM integration, but you can play with a lot of things. You can do full RESTful API, and you only have 1 spine, 2 leafs, and 1 APIC. Okay? So definitely make use of DemoCloud or dcloud.cisco.com.